Hello everyone, my name is Shreya Pramod Babar from TY BTech doing Computer Engineering Division D from MIT OE Alandi. Today I will be presenting on the topic optimization of loss function and best fit line using gradient descent. This concept is a fundamental part of data analytics and machine learning. It helps us understand how computers learn patterns from data automatically. So let's begin. So first, let's talk about regression. Regression is basically a way to understand how one variable affects another. For example, how someone's salary increases with experience or how a house price changes with its area. It's used when we want to predict continuous values, things like prices, marks, or temperatures. The main goal here is to find a best fit line that shows the trend of the data. So the simplest form of regression is linear regression, where the relationship between x and y is represented by a straight line. So linear regression equation. The equation of that line is y is equal to mx plus c. Here M is the slope. It tells how steep the line is or how much y changes when x increases by 1 unit. So here C is the intercept, which tells us where the line cuts on the y-axis. Other task is to find the perfect values of M and C so that our line fits the data in the best possible way. This line becomes the foundation for marking future predictions. Best fit line. So now let's see what exactly is a best fit line. Imagine you have a bunch of scattered data points on a graph. Our goal is to draw a line that passes through them in such a way that the distance from each point to the line is as small as possible. Some points will always be a little above or below, and that's okay. The line that minimizes the total error across all points is what we call the best fit line. Once we get this line, we can use it to make predictions for new data. Loss cost function. Now that we have drawn a line, we need to check how accurate it is. And for that, we use a loss function, also called the cost function. It basically measures how far our predicted values are from the actual values. The most common loss function in regression is the mean squared error, MSC, and it's given by this formula. L is equal to 1 by n summation of yi minus y hat sub I whole square. Here yi is the actual value and y hat sub I is the predicted value and n is the number of data points. What we do is for every data point we find a difference between the actual and predicted values, square it, and then take the average. If the loss L is large, it means our line is not a good fit. The smaller the loss, the more accurate our predictions are. So basically, the goal of regression is to minimize this loss function. Need for optimization. Now the question is, how do we minimize this loss? We use a process called optimization. Optimization simply means improving the model, adjusting the slope m and intercept c to reduce the loss value as much as possible. If we don't optimize, the line might not fit the data correctly. The most popular algorithm used for this process is gradient descent, which helps a model automatically learn the best values for M and C through repeated updates. So optimization is basically how the model learns step by step until it gets the best possible line. What is gradient descent? Gradient descent is an iterative algorithm used for optimization. You can think of it like a ball rolling down a hill. At the top of the hill, the error is high, and at the bottom, the error is low. The algorithm takes small steps downhill, moving in the direction where the loss decreases fastest. Step by step, it keeps going down until it reaches the lowest point. That's the minimum loss. And the point where the loss is minimum represents a best fit line, the most accurate model. So gradient descent helps us automatically reach that perfect line by minimizing the loss function. Let's see how gradient descent actually works step by step. Step 1, we start with random values for m and c, just a guess. Step 2, calculate the predicted values using the equation y sub hat is equal to mx plus c. Step 3, compute loss using mean square error. We measure how wrong the predictions are by calculating the loss using MSC. Step 4, we find the gradients by partial derivatives. Like the formula here is the partial derivative of L with respect to M is equal to minus 2 by N summation of X yi minus y sub hat of I. And step 5, we update MNC using these gradients and a small factor called the learning rate, alpha. So here the parameters are m is equal to m minus alpha with respect the partial derivative with respect to partial derivative of L with respect to M with same goes for C. Step 6, we repeat this process again and again until the loss stops reducing. That means we have reached this best possible fit. So each iteration makes our line more accurate and reduces overall error. Learning rate. The learning rate represented by alpha is a small number that decides how big a step we take in each update. If alpha is too large, we might overshoot the lowest point and never settle. If it's too small, the process will take too long to converge. So choosing the right learning rate is super important. It ensures that the model moves smoothly and efficiently towards the minimum loss. In simple words, learning rate controls the speed and stability of learning in gradient. Here, let's take a small example to understand this better. Suppose we have three data points 1, 2, 2, 4, and 3, 5. We start with m is equal to 0 and c is equal to 0. Using the equation y sub hat is equal to mx plus c, we calculate predicted values, then compute the loss using mean squared error MSC. Gradient descent then updates m and c repeatedly to reduce that loss. After several iterations, the values stabilize around m is equal to 5 and c is equal to 0.5. That gives us the best fit line y sub hat is equal to 1.5x plus 0.5, which fits our data almost perfectly. Convergence visualization. During the gradient descent process, you will notice the loss value keeps decreasing with every iteration. At the beginning, the loss drops quickly because the line is improving fast. As we get closer to the best fit, the changes become smaller and smaller. Finally, the loss curve flattens, meaning the model has converged or reached its minimum error. On a graph, this looks like a downward curve and that slowly levels out. This is how we know the model has learned successfully. So to wrap up everything, regression helps us predict continuous values like prices or marks. The loss function tells us how far our predictions are from the actual values. The gradient descent helps us reduce that loss step by step by updating MNC. The learning rate decides how fast or slow that learning happens. Once the loss becomes minimum, we get the best fit line, which is the most accurate representation of our data. This whole process, minimizing loss through optimization, is the foundation of almost every machine learning algorithm today. Thank you so much.